Hello everyone and welcome back to our channel mootechie. A special welcome to all the dairy technologists and students joining us for this third class in Unit 4. In our last session we covered the various methods for closing packages. Today we will move on to a highly advanced and critical area, aseptic packaging. We are now moving on to the topic of aseptic packaging. This technology is fundamental for producing shelf-stable dairy products like UHT milk. Aseptic packaging can be defined as the filling of a commercially sterile product into a sterile container. This entire process is carried out under aseptic conditions, and the containers are hermetically sealed so that reinfection by microorganisms is prevented. This ensures the product remains safe and stable. This slide shows an image related to aseptic packaging systems. The word aseptic is derived from the Greek word septikos, and it essentially means the absence of microorganisms. The result is a product that is shelf-stable at ambient conditions, requiring no refrigeration until opened. Achieving this sterility is complex, and there are many potential hazard points in an aseptic packaging line where contamination could occur. These include the connection points between the tank and the filler, the pipes themselves, the lips of containers, the seals, the containers and their lids, the sealing device, the filler mechanism, and various joints and joint zones throughout the system. Vigilance is required at all these points. The overall process flow for aseptic packaging involves three key stages. First, the sterilization of the product itself. Second, the sterilization of the packaging material. And third, the aseptic filling of the sterile product into the sterile package. The detailed process involves several critical steps. The product must be sterilized before filling, typically using a UHT process. The packaging materials or preformed containers and their closures must also be sterilized. The entire aseptic installation, including the UHT unit, product lines and the filler, must be sterilized before operation using sterile air and gases. During operation, sterility must be maintained throughout the total system, which includes sterilizing all media entering the system like air and water. Finally, the process must produce hermetically sealed packages. The sterilization of the product is commonly achieved using steam in heat exchangers. This can be done through indirect heating methods using equipment like plate, tubular, or scraped surface heat exchangers. Or it can be done through direct heating methods where steam is injected into the product or the product is infused into a chamber of steam. The sterilization of the packaging material can be achieved through various methods. Irradiation techniques include using ionizing radiation, plasma, UV lasers, or pulsed light. Heat-based methods include applying dry heat or saturated steam under pressure. Chemical treatments are also very common, particularly using hydrogen peroxide or peroxyacetic acid, known as PAA. There are also latest methods of sterilization being developed. These include using microwaves, electrical resistance heating, high voltage discharge, and ultra-high pressure processing. This slide shows an image of a system used for the sterilization of packaging material. An aseptic filling system is a coordinated setup. It includes a holding tube to ensure the product receives the required heat treatment, a cooling section, and sometimes a deaerator that uses a vacuum on a continuous flow to remove dissolved air. An aseptic surge tank holds the sterile product before filling. The system uses sterile air and a complex valve system, all driven by pumps designed for aseptic operation. A key feature in many aseptic fillers is the aseptic positive pressure chamber. This chamber is maintained under a slight positive pressure, about 1 mm of water column. It is installed between the zone where packaging materials are sterilized and the point where filling and sealing occur. This positive pressure ensures that any air leaks are outward, preventing contaminated air from entering the sterile zone. The air supplied to this chamber is filtered through a high-performance HEPA filter, often with a pre-filter that removes particles as small as 0.3 micrometers. Thank you for joining this class on the principles of aseptic packaging. We have covered the critical steps of sterilizing both the product and the package, and the controlled environment needed for filling. This technology is what allows us to enjoy safe, long-life dairy products anywhere in the world. In our next class, we will look at the specific machines that make this possible. Thank you. See you in the next class.